Hello! In this interactivity, we're going to find the relationship between the charge and the current. Recall that the ampere, A, is the unit for measuring current, and the coulomb, C, is the unit for measuring charge. A charge of 1 coulomb is equal to the total charge carried by approximately 6.25 times 10 to the power 18 electrons. The value of the current is equal to the rate of flow of the charge. This can be written as I, which is the current, is equal to delta Q, which is the change in the charge transferred, divided by delta T, which is the change in the time elapsed. So, delta Q is equal to I multiplied by delta T, where I is the current in ampere, delta Q is the charge transferred in coulomb, and delta T is the time elapsed in seconds. 1 coulomb is the charge transferred when a current of 1 ampere flows for 1 second. Let's click Start and watch the clock and the charge counter. Now let's click Stop. Why is the number on the charge counter equal to the number on the clock? We notice that the clock has a number of 6.6 seconds and the charge counter is 6.6. So why is that? Absolutely, because the charge is equal to the current multiplied by time, and the current is equal to 1 ampere in this circuit. So, the charge is equal to the time. Let's click Reset. We're going to use the slider to set a different value of the current. We'll set it to ampere, for example, and let's click Start. And let the counter run for a few seconds. Now let's click Stop. Multiply the value of the current by the time on the clock. What do you get? How should your answer compare to the value on the charge counter? Yes, it should be approximately the same. Any discrepancies are due to the accuracy of the measuring instruments. So, the charge counter is equal to the current multiplied by the time elapsed. That's all.